Okay, boys and girls, today we continue our lesson number 6. We're talking about free fall. Okay, free falling. So, free falling, that means that is happening without air resistance. Okay, happening without air resistance. So later on we'll learn another case is with air resistance. Okay, but when we saw about free falling without air resistance, we saw vacuum. All this keyword actually is under this chapter, this topic. Okay, it's talking about free fall. So before we continue, we're having a look of the video. So for this one video, okay, this is without air resistance. With air resistance, this is with air resistance. Now it's without. Okay, one more time. With air resistance, the ball will drop first. Feather will be later because there is air resistance, larger air resistance acting on the feather. Without air resistance, no matter what is the size, what is the shape, what is the mass, both of the object will drop at the same time and reach to the ground at the same time. How to stop? Okay, so boys and girls, we come back to our lesson. Okay, free fall. Free fall, that means that without air resistance, without air resistance, sometimes you saw the keyword of vacuum. Okay, that means under the topic of free fall. Just now the video show you that if there is no air resistance, actually, we don't care about the shape. We don't care about the size. Both of the object actually, they will reach to the ground at the same time. Okay, so what force acting on the object? Without air resistance, there is only one force acting on the object. What is the force? Okay, the force that due to the gravity called weight. Okay, so both of the object, the only force that acting on the object is weight. Okay, write down weight. No air resistance. Okay, they does not encounter air resistance. No air resistance. Okay, free falling only in vacuum because we don't want air resistance, so only in vacuum. How they fall? You look at here, t equals to 0 second and t equals to 1 second. Initially, u equals to 0. Then after that, v becomes 9.8 meter per second. So if I calculate it, we will find out that, okay, every 1 second, they increase 9.8 meter per second. Okay, from 1 second to 2 second at here, okay, they also increasing another 9.8 meter per second. Then from here, again increasing 9.8 meter per second. Okay, so boys and girls, can you see that every 1 second, the speed is increases. Okay, from 9.8 meter per second become 19.6 meter per second, become 29.4 meter per second. Every 1 second speed increases. So how we describe the motion? It is acceleration. Okay, it is accelerate. Okay, the acceleration is constant acceleration. Every 1 second, they increase 9.8 meter per second. Every 1 second, they increase again. So can you see that speed increases? We call it as acceleration. Then we can say this is constant acceleration. Okay, we will drop at the acceleration at 9.8 meter per second per second. Okay, this is the free falling acceleration on Earth. Okay, due to our Earth gravity. Okay, so acceleration meanings what? Speed increasing. Acceleration meanings that speed increasing. Okay, then just now the video show you that it doesn't depends on size, shape, or the weight, mass. Okay, also doesn't depend on the mass. Okay, we learned last week what is the weight. Weight W equals to mg. Okay, So at here, as long as it's free falling question, so you need to always remember the speed is increasing and then they are moving with constant acceleration. Every 1 second, they are constantly increases the speed. Okay, so if there is a graph here. Acceleration, how was the graph shape? Will showing you. My answer is constant acceleration. So this value is 9.8. This is meter per second square. 9.8 meter per second square. It will be a horizontal line to showing constant acceleration. Is it okay? Okay, speed time graph. If they're asking you about speed time graph, we know that increasing speed. Speed will increases. So at here, going up like this. Speed increases. So these two graphs you have to know. This is free falling graph. So acceleration of free fall g, okay, free fall g near to our Earth is actually 9.8 meter per second square. Okay, until here, any question? If no question, can you give me reaction? Then we go to the past year question right now. Okay, how about others? Only one? Okay. Okay, boys and girls, we come to this question. A large stone is dropped from a bridge into a river. Air resistance can be ignored, like underline. When they say ignore air resistance, you write down free fall question. This is the question related with this topic called free fall. Okay, what is the acceleration and what is the speed when the stone it falls? Type your answer on the chat box. This is easy question. Boys and girls, show me your answer. Okay, Hui Tong already give me the answer. Answer is correct. Answer is B. Constant acceleration. Constant acceleration. Where is this? Okay, constant acceleration. Then speed is increasing. Okay. Next, this is 2024 question. This right now. A coconut falls from a palm tree at X, at this position at X. It just start falling at point Y. It's the point just before it hit the ground. Okay, before it hit the ground. What is the acceleration of the coconut at X? What is this acceleration? Air resistance can be ignored. So I know this question asking about free fall. Okay, boys and girls, tell me your answer. Respond to me, dear. Any of you? Question number 2. No, Hui Tong, no. Emily. Emily, I just calling you. Correct, Emily. Okay, dear, let me have a look. Megan, correct. Okay, dear, here, we know that here, as they're falling from here to here, acceleration at point X must be equals to acceleration at point Y because they are constant acceleration. So answer should be C. Okay, answer should be C. What is zero? At starting, what is zero? The air no air resistance, nothing. Air resistance all the time is zero. Yes, air resistance all the time is zero. No air resistance. Okay, so answer is C. Any question? No question. We go to your next page. Okay, thank you, Hui Tong. The boys and girls, we go to question number 3. On Earth, a ball is dropped and fall 2 meters in a vacuum. Highlight, underline vacuum. Once you saw vacuum, also the topic about free fall. The acceleration of the ball is 10 meter per second. Teacher, you're not telling us that the acceleration is 9.8, meh? Okay, listen to me. 9.8 is the value that after we having our new syllabus. 2023, starting from 2023, we are following the new syllabus. So they changed from 10 to 9.8. Okay, so if you're doing the past year, which is earlier than 2023, they will using the G as 10 meter per second square. Okay, so at here, because this is 2017 question, so they still using 10. Okay, they say 10. At 1 meter here, the acceleration is 10 meter per second square. So they will ask you, what is the acceleration at the ball of 1.5 meter? What is your answer? Okay, from Megan. Correct, answer is correct. How about Hui Tong? I want to know about Hui Tong. Acceleration at here. What do you think? You can refer back, Hui Tong, you can refer back to just now this question. Okay, let's say this one is 0.1 meter. Then this one is, I don't know, maybe 0.8 meter. Your acceleration, what's going on? So you come back to this question. So at 1.0 meter, acceleration is 10. So at 1.5 meter, you also need to have 10 meter per second square. Yes, correct, Hui Tong. So this is constant acceleration. So they changed the way to ask, but actually it's testing you on the same concept. Okay, we goes to your question number 4. Okay, boys and girls, we goes to question number 4. A ball is dropped. Okay, this one actually is meaning that in the vacuum tube. Okay, vacuum tube. If vacuum, that means that free fall. So they're taking the photo, ta 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 ta. Okay. So another ball of same size but twice the mass. The mass is bigger lah. Okay, it's dropped at the same position. It drop it down and then capture. Which diagram show the motion of the heavier ball? So this is the first ball, reference ball lah. I say reference ball. So they wants to A, B, C, D. Which one is the heavier ball? They drop in the same environment, which is the vacuum environment. So A, B, C, D. Licious, what do you think? Correct, Hui Tong. How about others? Licious, Xuan. How about others? Any of you? If you have no idea, you refer to your page 1. If you have no idea, you refer to your page 1, the diagram. Correct, Megan? Okay, for this part, actually it's same as our first page just here. Can you see that? 2 objects. So we can say this one is mass, this one is double mass, just now the question. So the capture at time equals to 0 second, 1 second, 2 second, 3. So which one is the correct one? You see, first ball, second ball, third ball, fourth, and fifth. Which one actually is exactly the same? My answer is B. B. Okay, B will exactly showing you the same. Okay, B. Any question? You see this one? The position is exactly the same. Any question, dear? Give me response. If no question, we goes to page number 4. Okay. Okay, dear, number 4. 4 balls with different mass drop from the same height. Air resistance can be ignored. So again, this is free fall question. Which ball has the greatest average speed? A, B, C, D. Which one actually, when they touch just before to the ground, just before they touching to the ground, which one will actually having the greatest speed? A, B, C, D. So you imagine you drop something from 1 meter, you drop something from 2 meter, 3 meter, and 4 meter. Which one at the end they reach to the ground having a largest speed? Answer, tell me the answer, dear. Correct, Megan? Okay, boys and girls. Okay, because we are acceleration, object will accelerate, right? Okay, accelerate at 9.8 meter per second square. Accelerate meaning speed will keep on increasing. It will keep on increasing with the time. Okay, so we come back to your first page here. Can you see that? If your height is like this only, so actually the speed is slow. Okay, only 9.8 meter per second. If your height is quite high lah, okay, something like this at here, so you will found that from 0 second to 1 second, 2 second, 3 second. At 3 second at here, when they reach to the ground, it become almost 30 meter per second. The speed increasing. With the height at here, actually you provided enough of time for it to increasing the speed. So for this question, answer is it should be donkey. It should be donkey. What's going on? It doesn't allow me to draw circle. Okay. Any question, dear? Okay. Number 6. Free fall. Free fall. And air resistance may be ignored. So at here, can you tell us which graph show how the acceleration is changes? How the acceleration is changes? A, B, C, D. Thank you, Megan. How about others? Hui-Tong, correct. Okay, boys and girls, answer will be donkey. Okay, you have to. So this what's wrong with this? The good note actually I pay 100 something for the buying to use it. At the end, it keep on like jump out. Okay, boys and girls, answer will be D. Constant acceleration, which is 9.8 meter per second square. Okay, no question. We goes to your page 5. Coconut falls from position X to Y. What causing the coconut to accelerate? Okay, now you can change the coconut to become the apple. Okay, the apple falling and hit the Newton's head. What causing the apple fall down? What caused the apple falling down and accelerate? Any of you know the answer? Can you write it down for me? Gravitational force. Yes. It's the force due to the gravity. We call it as gravitational force. Yes. Or we might be say the weight causing it to accelerate. Okay? Can you compare the acceleration at position X and position Y? Can you compare there? What do you think? First, second, or third box we have to tick. What is the acceleration? Third one, thank you. Pritong, thank you. Okay, you see about the same. Teacher, you say it's the same. What? Why now? Right now you say about the same. Because in this question, they didn't really mention about air resistance is ignored. That means that it might be having some air resistance. So at here we say about the same. So we maybe it will be affected a little bit by other forces. Okay, so at here is about the same. Okay, boys and girls, can you sketch from falling from X to Y? How was the speed? Just now it's asking you acceleration. We understand that it's a constant acceleration. Right now the speed is increasing the speed. So your graph should be like this. Okay, we already learned about motion graph, am I right? That day I asked you capture into your brain. What is that? Okay, the distance, time graph, speed, time graph, then acceleration. Okay, from distance to speed, we find gradient. Using distance time graph, we find gradient, we can find the speed. Using speed time graph, we find the gradient, we can get the acceleration. Okay, from the speed, we find back. To find distance, we can find area under the graph, right? Okay, now this is the motion graph. They're asking you how you determine the distance xy. Okay, how you determine the distance xy from here to here, how far they travel, xy. Okay, by using the graph at here. Normally from the graph, two information we can find, gradient or area under the graph. So in this, can you tell me, is we finding gradient or we finding the area under the graph? What do you think? What do you think? Any of you? Okay, Megan, let me have a look. Area under graph, okay? Area under graph. So at here, we can determine by finding area under graph. Okay, boys and girls, before we proceed to the page number 6, we rest for 1 minute. I went to the toilet for a short while, 1 minute. Okay, I'm here. Okay, just now we learned without air resistance. Now we learn with air resistance. Okay, let me have a look. I find the video. Terminal velocity. Okay. Where is the video that I want? I want this. Okay, dear, we look at here.
Kuasai hari anda dengan cara tersendiri bersama Bijadin Sarapan Milo. Kerangupan penuh tenaga dengan Bijadin.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes through.
Okay, when the object falling down in the air resistance, Xuan, later on I go back to one slide. Okay, deal. When we falling down and experience air resistance, so I want you to observe what is the changes of their motion. Okay, changes of their motion. So first,
Some big changes.
so I want you start from right now. Observe this is the speed. Okay, here we got three motion. Here is very short, but actually got three type of motion. First, when object falling out, it don't have the air resistance yet. Once it jump out, it don't have air resistance yet. So at the moment, it's only have weight. It's only have weight. So the object accelerate at 9.8 meter per second square. So they are increasing the speed. So you observe, starting they increase the speed very fast. Increasing the speed. But after that, when they near to 40 something meter per second, 40 something, you observe the speed, how it increases. They're still increasing the speed. They're still increasing from 40, 41, 42. But you have found that at the moment, they're increasing the speed, but not that fast. Okay, but not that fast. They accelerate. Their acceleration is slow down already, lower acceleration until they goes to 55 meter per second. You will find that objects still continue falling, but the speed still maintaining at 55. So we repeat and watch the video one more time. Okay, we observe what I telling you just now. Three motion. First, it accelerate, fully accelerate. After that, you will find that as air resistance will start to acting on the object, so they were having some upward force air resistance. You will find that it's still increasing the speed, but not that fast. The acceleration is decreases, still increasing the speed, but not that fast. Okay, until a certain moment, they become 55 meter per second. They maintain the velocity. But are the object falling? Yes, it still continue falling. Okay, observe one more time. Open the parachute. Okay, later on the second part, when they open the parachute, suddenly we got very high air resistance, okay, exerted on the object. So very high air resistance, actually it will make it slow down. Okay, so from 55, it decrease until 5 meter per second. You are finding that it's still falling down, but it maintains another terminal velocity, or we say constant velocity. So today we are going to learn why and at what moment why it become constant velocity. Okay, so this is the topic that we are going to learn right now. Okay, before that, we let Shuan go back here. Okay. Shuan, if done, then you let us know. Okay. Yeah, actually, I got recording the video. If any of you need to revise, okay, with the video, so you can send me your email address, then I will approve you. Okay, you will receive the email. So from the email, you can click the link and then you can go through the file. Okay. So next, falling through the A. Just now free fall is no A. Right now is with A. Okay, we fill in the blank. At starting, when they jump out, the air resistance actually is 0. No air resistance at start. Okay, so he accelerate downward. Okay, so it accelerate at 9.8 meter per second square. So at here, they only have weight. Weight only. Okay, weight only. So it accelerate at 9.8 meter per second square. So this one, the net force is 800 newtons. Do you remember how to find net force? If same direction, at the opposite direction, big force minus small force. Okay, accelerate meaning speed up. Am I right? Accelerate meaning that is speed up. Okay, so speed increases because accelerate. When your speed increases, your air resistance will also increases. Imagine you walking, you won't feel any air resistance. But when you are start to run, you can feel the air resistance. Okay, so at here, we start to have air resistance, but air resistance still less than your weight. Okay, less than your weight. If according to the number that I simply put, you will find that now your resultant force is 500 Newton. You're using 800 minus 300. So this is 800 minus 300, you get 500 Newton. Can you see that? Your actually net force decreases. Your net force decreases. Net force decreases. When that net force decreases, just now until like almost 40 something to 50, you found that it's still increasing. It still accelerate, but not that fast. The speed increase. Okay, they slow down 48, 49, 50, 51, 52. They slow down. It's because acceleration right now is actually decreases. It might be having acceleration. I just simply give some value. It might be like 5, 4 or something. Okay, it's slow. It's less than 9.8 already. Okay, it will less than 9.8 already. Okay, then after that, because you still accelerate, what dear? You still accelerate. You see here, you still accelerate. That means that your speed still increasing. Speed still increasing, but at a slower rate only. If you are speed increasing, your air resistance will keep on increases. So can you see that this air resistance, this is air, this is weight. Your air resistance from 300, it will continue increases until 800 Newton. At this moment, actually your air resistance will big enough to balance the weight. So which means that your air resistance equals to your weight. If at this moment your net force is 0, net force is 0, what does it mean? When we learn about force and motion, we talk about balance force and unbalanced force. When net force is 0, this is called balance force. Okay, the force are balanced. So when the force are balanced, we got two motion. One is, okay, here I recall. Force we can divide it into two. One is called balance. One is called unbalanced. Okay, if balance, for example, the object moving here 10 Newton, here also 10 Newton. This is called balance. When balance, net force is 0. Okay, so there is two types of motion. One is maybe object at rest. Another one is maybe moving with constant velocity. Okay, we learned this already. If don't know, then please go back and study again our worksheet regarding force and motion. I think it's the first lesson of the force and motion chapter. Okay, let's say unbalanced force. This is 20 Newton. Here is maybe like 8 Newton. So what is your resultant force? Your resultant force, or we say net force, is 12 Newton to the right. So at here, unbalanced, that means that your net force is not 0. So they will have three types of motion. One is maybe object accelerate, maybe object decelerate, Third, maybe object moving in circle. Okay, this one we already learned. We already learned. So can you see that just now I start at here, our resultant force is not zero. Our resultant force is not zero. That's why it is acceleration. Okay, it is acceleration. But when we achieve balance force, upward force equals to downward force. So we got two possible motion. Either it's at rest or either it's moving at constant velocity. In this case, it's falling down. Okay, in this case, this is falling down. So that means that it's moving. If this is moving, so we can say that object is their speed, his speed is become constant speed or constant velocity. In this topic, we can call it as terminal velocity. Sure can, after this, I import out this PDF file. Okay, I can send out. For those, if you need to write down, then you can write down right now. If done, then you give me some response, then we understand that we can go to your page number 7. Done? Okay, Megan said okay. How about others? Emily? Y10 okay. Emily? Okay, done. Then boys and girls, this is the first three part, okay? Before it open the parachute. So if according to the video just now we are reaching the 55 meter per second. Now we goes to the next page. Sure, this part okay? Can we go to page 7? Okay, dear here, we suddenly open the parachute. Air resistance suddenly increases. Here increases. But boys and girls, you don't tell me that object moving upward. You don't tell me that object moving upward. It still continue moving downward, but it is slowing down. Okay, cause it to decelerate. Decelerate meaning that slow down. Okay, slow down. So your net force actually right now is actually going up. So this one is 400 Newton, but it's going up. Okay, so your acceleration right now actually is a upward direction. It's a negative. Okay, it's a negative because it's oppose your motion. So actually it's slow down. You don't tell me that object move up. Okay, air resistance now is greater than your weight. It make it slow down. Right, imagine you are running, suddenly a strong wind blowing towards you. You don't tell me that you move backward. You just very hard to move forward in a higher speed only. Okay, you still can moving forward, but it make you slow down. Okay, then since we decelerate, decelerate meanings what? Meanings that your speed decreases. If your speed decreases here, slowing down. Okay, so this one slowing down. Air resistance will increase or decrease? Since slowing down, speed decrease, air resistance will also decrease. That's why you see it decrease until at a certain moment it balance with your weight again. So still remember just now the video, the last part, it will be moving, continue falling down at 5 meter per second at that velocity. Okay, so now they balance again. Net force is equals to 0. They balance again. Force is balanced. Okay, so again, they're moving with constant speed. Okay, we can call it as lower due and lower terminal velocity. We achieve another constant speed. Constant speed we call it as terminal velocity. Okay, any question you want to ask? Any question? Okay, no question, Okay, here the bottom part summary is very important. It will helping us to do explanation in your paper 4. Okay, we take paper 2, 4, 2, and for me, my school is 6, 2. Okay, your school, I depends on your school. Maybe you're doing practical or alternative practical, it depend. Okay, we look at this part. This one is very important. Actually, all the points here. At start, we only have weight. Object will accelerate, fully accelerate at 9.8 meter per second. The resultant force is very big because only weight. This is the only resultant force. After jump out, okay, a short moment, we start to having air resistance. So here, air resistance. Air resistance is small, weight still a bigger one. So you will find that your resultant force is decreases. Okay, your resultant force here, resultant force or net force decreases. Your acceleration decrease. Accelerate is still accelerate, but not that fast. So we say acceleration decreases. Okay, so at here until a certain moment, terminal velocity is achieved when air resistance equals to your weight. Air resistance equals to your weight. So at this moment, your resultant force, or we say net force, is 0. When 0, we achieve terminal velocity. Okay, we achieve terminal velocity. After that, we having a large parachute, we open it, so the air resistance become very big. So can you see the size? Okay, longer, air resistance longer. That means that this one is higher force, okay, for air resistance. Object will decelerate. That means that speed slowing down. Okay, speed slowing down, air resistance will slow down. Until a certain moment, they are balanced again. So resultant force is equals to 0. Why I say this diagram is important? They like to asking you 3 to 4 mark. Ask you describe the motion in terms of force. What is your motion? This part is your motion. They're asking you describe your motion. So this part is actually the motion. What happened to acceleration? What happened to, if here terminal velocity, that means that your acceleration will become 0 already. Okay, it decreased from 9.8, decreased to 5, 4, 3, 2, 1, 0. When the acceleration becomes 0, no accelerate, no speed up. It maintain constant speed. Okay, so this is the motion. In terms of force, what is in terms of force? You explaining about this and the resultant force. You say at start only weight. Okay, resultant force is big. Motion object accelerate. After that, we will have air resistance. Then smaller resultant force, acceleration decreases. At a certain moment, air resistance increases because of the speed. It balances with the weight. Resultant for 0, acceleration 0, it achieves terminal velocity. Air resistance is very big, suddenly increases because we open the parachute. So the object decelerate. Okay, air resistance greater than weight in terms of force, explaining. So it decelerate. Okay, so decelerate meaning slow down. When slow down, your air resistance also decreases. Okay, so at here, your air resistance will decreases until air resistance equals to your weight. Okay, then again, what is the motion? Terminal velocity. Because of resultant force is 0. So at here, in terms of force, explaining the motion. This diagram is important. Okay, can I proceed to the page number 8, dear? Can I proceed to page number 8? Okay, thank you. So we goes to page number 8. This is the velocity time graph. So can you see that at start here, they fully accelerate. After that, they will start to decreases. They will start to decreases. But actually, can you see? Speed still increase. Speed still increase. But they are not that fast. Supposedly like this. Okay, but they're not that fast. They're slowing down the rate. Okay, so at here, at first, air resistance is small. So object accelerate higher rate. Okay. Then air resistance speed up, air resistance increase. So it will slow down the acceleration. Okay, so this part acceleration decreases. At start at here, okay, acceleration is 9.8 meter per second square. So after that, along the line, they start to decreases until when? Until here, you highlight this part and this part. These two part is called terminal velocity. Until it achieve constant velocity. Or we say constant speed lah. Okay? So at here, when the parachute is open, there is a large upward force because air resistance cause the object to decelerate. Decelerate meaning speed decrease. Can you see that? Speed suddenly from a certain value decrease down. Okay, eventually at the end, the force is balanced. Okay? Any question? If no question, we try with past year question. We see how the question they're trying to ask us. Is it okay? Okay. Only Megan okay? How about others? Still digest? Okay. Like boys and girls, question number 1. When does object falling vertically through the air, it can achieve terminal velocity? When it achieves terminal velocity. What is your answer, dear? Yes, correct. Hui Tong, answer is C. When air resistance equals to the weight, it achieves terminal velocity. Yes, correct. Okay, number 2, a light object, light. Okay, a light object is dropped from rest. It falls a large distance vertically through the air. So this one we have to consider A. How can the motion of the object be described? Light object falling down. Can you describe its motion? Any of you? A, B, C, D. No, Hui Tong. How about others? Any others? You guys don't have idea what is the answer for this question? It's falling down. After that, it start to gain air resistance, experience air resistance. What's going on with the acceleration? And then because of the air resistance will keep on increasing. So at the moment when the air resistance increase until big enough, what's going on? What is your answer? Any others? If you guys didn't give me response, I will not know that whether you get the point or not. So if you make mistake, then I know that I can trying to figure out what is your problem and which part you not understand. So please let me know. Okay, Megan, answer is correct. It will decreasing acceleration because at certain moment, okay, they start to have air resistance against the weight. Until a certain moment, the air resistance big enough to balance the weight. So at here, initially, you only have weight. At this moment, you are accelerate at 9.8 meter per second square. At a certain moment, your acceleration maybe is only 5 meter per second square. Until a certain moment, it balance. Okay, the air and the weight is balanced, so your acceleration is 0. It's moving with terminal velocity. So your answer should be C. Decreasing acceleration at the end terminal velocity here becomes 0. So the acceleration will decreases until the end it become balanced. Acceleration is 0. Any question there? No question. I'm going to the page number 9. Okay, we goes to page number 9. Do you need to draw anything or mark down anything? Here they're mentioning light is because if your light object, that means your weight is small weight. If small weight, it will be very easy to achieve terminal velocity. It's because the weight is small, then small air resistance is needed to balance it. That's why they're mentioning about light. Okay, light meaning small weight. Small weight, that means small air resistance is needed to balance it. So that means that easy to achieve terminal velocity. Okay, any question? Can we proceed to the next page? Okay, let's go. Okay, like boys and girls, this is the weight and air resistance. But the ball not yet achieved terminal velocity. Okay, not yet. So number 3, which row showing about the resultant force and what happened to the acceleration? Okay, what happened to your resultant force compared to initially we dropped? Megan have to think again. Is it you want to give me the answer for this question? But the answer is not C. Like boys and girls, what do you think? Resultant force. Initially, only weight. Then after that, we start to have air resistance. So this resultant force is actually fully weight. This resultant force actually is the weight have to minus the air resistance. Let's say here is 10 Newton. Here is 2 Newton. What is your resultant force? 8 Newton. For the starting at start, okay, T equals to 0. Resultant force is here, let's say 10 Newton. So you are fully 10 Newton. So if you compare, you will find out that this resultant force actually is decreases. Am I right? If your resultant force decreases, you will not accelerate that fast. You're still increasing the speed, but not that fast. So answer should be A. Is that clear, everybody? Any question? Okay, no question. Megan, correct? Okay. So here, number 4. Skydiver jumps from a stationary helicopter and reach a steady vertical speed. Steady speed, that means constant speed lah. Steady, that means constant. She then opened her parachute. What statement about the falling skydiver is correct? Okay, read the answer A, B, C, D, and then choose the answer, and then type your answer to me. You are allowed to make mistake, no need to shy. We don't know each others. You know me, I don't know you. So you don't need to be shy to tell me your answer. You respond to me, then I'm trying to understand which part you not understand or which part concept is wrong. Okay? Try to give me response, thank you. Which statement about the falling skydiver is correct? For this question, it might be slightly difficult, but you can choose those is wrong one, then you cross, choose the most correct one. Any of you? Number 4, what is the answer that you think? Megan, correct. Good job. How about others? We look from the D first. Fall with steady speed, that means constant speed. When constant speed, air resistance 0, wrong. When constant speed, air resistance should be equals to your weight. It's not 0. It should be equals to your weight. Okay, when she accelerates, see, when she accelerates, resultant force is 0. Wrong. Resultant force will not be 0. Why? Just now here, this case, I told you. Where is it? Oh, here. When accelerate, it won't be 0. Resultant force impossible is 0. It must have some certain larger force to make it speed up. Okay, larger force to make it speed up. So it's not 0. So this one is wrong. Accelerate, it not be 0. It's unbalanced force. It must have some resultant force. Okay, B, as she falls at steady speed, when her parachute open, suddenly parachute open, your weight will become 0. Your weight never be changed what? Your weight will not be 0. It will remain the same. Get it? So if you go back to all this diagram, you see from starting to ending, 800, 800, 800 weight, 800, 800 weight. The weight never be changed. Okay? Never be changed. W equals to mg. The mass doesn't change. Your g on earth is 9.81. 9.8, sorry. In A level is 9.81. In your O level is 9.8. Okay? So it's the same. It won't become 0. So this one is also wrong. Okay? This part is wrong. The only answer is A. Okay, I'm going to explain why it's A. When she open the parachute, acceleration is upward. Okay, for example, this is the object. Okay, so at here moving upward, suddenly open parachute. So let's say it's become 1,200 Newton. The weight that just now I give you the example is become 800 Newton, right? The resultant force is become 400 Newton going upward, right? So your acceleration is follow the direction of the force. It will also upward. Okay, it will also upward. But because our motion is going down, we're still falling. So your acceleration is oppose your motion. So at the end, the acceleration that we get actually is a negative value. That's why we slow down. Okay, but what is the direction of your acceleration? Actually is follow this resultant force. It will be upward. Okay, it will be upward. So we can say that it's negative A lah, negative A. So answer is A. Any question? No, Megan say no. Good job. Okay, no. Then I'm going to your page number 10, question number 5. Okay, here. Weight of the skydiver is 750 Newton. The weight always pointing downward, must be pointing downward, okay? While the skydiver falling, another force will acting upward. The upward force will change. Varies means change. When the skydiver falls, it will keep on changing one. Okay, the skydiver is accelerating at the time 0 to 20 seconds. It will accelerate. Between the time 20 to 40, it will achieve constant speed. What we say is terminal velocity. On the diagram, write the name of the upward force. What is this upward force? Weight, bottom part. So your air resistance will be your upward force. The air resistance will change according to your speed. So when speed increase, air resistance will also increase. Is that clear? Is that clear, dear? Okay, then we're going down here. Okay, suggest a value of the upward force. What is the value for your air resistance? Upward force is air resistance. At the time 10 seconds. At time 0 to 20 seconds is accelerating. Object going down, accelerate. When it accelerates, can you tell me what is the value for this air resistance? Any of you can type your answer in the chat box. What do you think? Air resistance 0, greater than 0, 750 Newton? Or what is the value? You suggest one value. When time 0 to 20 seconds, you can refer back to the notes just now, the diagram. See when it accelerates, how was your air resistance and your weight? Your air resistance should be equals to 0, less than your weight, equals to your weight. Which one? Any of you? We can come here and see. Okay, here this first and second diagram is actually accelerate. It's actually accelerate. So you observe the air resistance. Your air resistance actually is still smaller than your weight. So object will accelerate downward. Until a certain moment, it balance. Until a certain moment, it balance. Okay, so at here, what is the value that we can suggest? This is 750 Newton. Since it accelerates, that means this part must be greater force. Okay, accelerate downward, that means this part must be a greater force. So your air resistance, you can suggest any value as long as smaller than 750 Newton. So for me, maybe we can suggest like 400 Newton. So we write here, 400 Newton. In answer scheme, they accept with any value less than 750 lah. Is that clear? Accelerate downward at time, accelerate. Okay, so object will be accelerate. It will having a higher weight but smaller air resistance. So in this moment, it will accelerate downward. Okay, determine the value of upward force for the skydiver at time 30 seconds. When 30 seconds at here, actually they achieve constant speed. Can you tell me what is the upward force? Constant speed. So what is your air resistance? No, correct. Thank you, Megan. It will achieve 750 Newton. At this moment, your air resistance must be equal to your weight. So since I know 750 Newton for the weight, so my air resistance also 700 Newton. 750 Newton. Is that clear, dear all? If okay, we goes to page 11. Okay, we goes to page 11. Okay, now it's using the graph to learn about the motion. Skydiver jumped out of the hot air balloon, which is 4,000 meters above the ground. At the time 30 seconds. Open her parachute. Figure 1.1 is the speed time graph of her fall. Label with the letter X. Where is your X? Okay, X point on the graph where the skydiver open her parachute. Open her parachute. So at here, this is the part it open parachute. So actually we should label at here. This is the point it start to having parachute. Okay, label with letter X. So we have to label this. Okay. Label with the letter Y and Z to show the skydiver falling with constant velocity or terminal velocity. This one meaning that constant speed. Speed doesn't change, maintain. So from where to where actually the speed doesn't change. So at here, this part and this part. Can you see that? For the upper part here, it might be maintained somewhere here, 60 meters per second, this one. Okay, for this one, it might be somewhere here, less than 10 but maybe roughly 8. It maintains the same speed. So at here, we should label Y at here, Z at here. Two parts. It's not a point, it's part. Okay, for the skydiver achieve terminal velocity. Is that clear? Okay, thank you, Megan. This is the part that I mentioned, 4 marks, you know. They ask you in terms of force. So when you're talking about in terms of force, you have to talk about weight, talk about air resistance, talk about their resultant force. This is in terms of force. Okay, describe their motion. Describe their motion in terms of force. Okay, so at here we have few steps. Okay, the first step is initial acceleration at 9.8 meter per second square due to weight only. Okay, so at here initially due to weight only, this is the force. How the motion accelerate. Okay, so this is the first part of motion. Okay, then we say air resistance is produced. Okay, and air resistance increases as speed increases. Okay, so this is number 1, this is number 2, talking about the what resultant force. So your resultant force decreases. Describe the motion. Acceleration decreases. So at here, resultant force, and we talk about air resistance. So we talk about motion. Okay, second motion. Okay, third. Since your air resistance will increase. Okay, air resistance will increase. So at a certain moment, okay, in this diagram, when at roughly 60 meter per second, or maybe at roughly 30 seconds, okay? So at 30 seconds, okay, the air resistance balance the weight. Okay, it balance. So resultant force is 0. Motion, describe the motion. The motion is now is 0 acceleration. Okay, so terminal velocity is achieved. Okay, so here air resistance balance the weight. Resultant force is 0 in terms of force. This is in terms of force. So this is the motion. So this is the motion. So this is the force, this is the motion. So this is the force, and motion. This one 4 mark, 3 to 4 mark. That's why I told you just now the first the diagram, summary diagram is important. The diagram actually helping us to summarize all the forces, what's going on with the force, what's going on with your air resistance, then what's happening with your motion. So I'm not going to continue talking about the parachute motion is because this question they said that between leaving the balloon and before it opened the parachute. So until this step is already good enough. Okay, so I give you 30 seconds to complete this. After you're done, you give me some response. After you complete writing down, then you give me some response, then we can proceed to the next page. Sure, later on you message me. I send you this file. Or any of you need this file, you also can message me. WhatsApp me. Then I will forward to you. Okay, if you finish for this part, let me know. Okay, Megan say yes. How about others? Megan already complete. How about others? Hui Tong okay. Emily, Shun, Licious. Emily okay. Licious. Shun. Done. Okay. Shun, yes. Okay, like boys and girls, we go to the ball. What they want to tell us? They want to tell us that they won't touching to your tube. Okay, it won't touching to your tube. So it will not create any friction at the side. Okay, so what will be affected? Only the weight and the resistance due to the liquid. Okay, so the ball is released. So it accelerates downward uniformly. Uniform means what? Constant rate. Steady rate, also constant rate. Okay, uniformly is constant rate for a short period of time. It will accelerate downwards. Okay, describe what happened to the velocity. Accelerate. So your velocity will be accelerate. That means that your velocity is increases. Do you agree? Accelerate meaning speed up. Okay, so your velocity increases. 2 mark at here. One more mark. What is that? Oh, angry. 2 mark at here. 1 more mark. Where is it? Okay, 1 more mark is talking about the uniformly. So how it increasing the velocity? It increasing velocity at constant rate. At start, they're increasing at constant rate. For example, it increasing initially is 9.8. If in the A initially is 9.8 meter per second. So it will maintain a very short period before the air resistance come out. So for the ball also the same. They start before the drag force they're producing in the liquid come out. So they will be increasing the velocity at constant rate. Okay? The ball will reach the terminal velocity. Describe and explain the motion of the ball when it is released until it achieves terminal velocity. You see these two questions, one is in the air, one is in the liquid, but actually the answer, how we answer this question, exactly the same. So what we say, initially acceleration is 9.8 due to the weight only. So I refer back to just now the question, actually it's the same. Initial acceleration, but you don't say 9.8 lah, because this is inside the liquid. So initial acceleration due to the weight only. Okay, then after that, you don't say air resistance, you say resistance due to the liquid is produced. And the resistance increases as the speed increases. Resultant force decrease, acceleration decrease. Okay, then after that, you say that at the end, the resistance balance the weight. Okay, resultant force zero, zero acceleration, terminal velocity is achieved. Exactly the same way how we answer. Just you don't mention 9.8 because 9.8 is in the A. Now we are in the liquid, it's not 9.8, okay? So you don't say air resistance. Air resistance is in the A. We can say drag force or resistance force, okay? It's producing. So at here, okay, we write down. Okay, initial accelerate due to the weight only. Okay, then after that, you can say this is drag or you can say resistance force. Don't say air resistance, okay, it's produced. Okay, the drag, I'm using drag force, drag is increases with speed. Speed increase, it will increase also. Okay, so your resultant force decreases, your acceleration also decreases. So 1, 2, okay? Number 3, okay? Finally, drag is balanced, or we say weight is balanced. Balanced by the drag. Resultant force is 0. Acceleration is 0. So terminal velocity is achieved. Okay, exactly the same as just now. But you need to depends on the situation to answer it. You don't at here still talking about air resistance. You don't hear mentioning 9.8 because this is not in the A. In the liquid, they got some other factor to slow it down. Is that clear, dear? If done, let me know, dear. Let me know. Is it okay? We got 4 more minutes. Do you want to proceed to learn something new or you want to stop at here? You let me know. Now it's 9:26. If you want to continue the 4 minutes, then we continue page 13. If you feel that today is enough, okay? I learned 2 topics, it's enough for me. My brain going to explode. Okay, you want to stop at here, you let me know. Any representative, tell me. Are we going to proceed? No. Okay. No, okay. So today we learn free falling. We learn without air resistance is called free fall. So 2 points I want you to remember. Constant acceleration and speed increases. It won't affecting by the size, shape. No, doesn't. Okay. Then second part we learn about with air resistance. So with air resistance, you have to understand the air resistance will be increases with your speed. Speed increase, air resistance also increase. So when there is air resistance, actually resultant force is decreases. So the 800 minus 500, you get only 300. Acceleration will decrease also. At the end, terminal velocity is constant speed, the weight balanced by the drag. So resultant force is 0, that means balance force. That's why we say balance. Acceleration 0, terminal velocity is achieved. Okay, any question for today's lesson? If no question, actually we can stop at here. If no question, give me response yes. Thank you, Hui Tong. How about others? Okay, so stop my video.